What message recently came from Voyager 1? Yes, it's the same spacecraft exploring the cosmos in search of other life and new discoveries. It went missing, then suddenly started communicating again. Can you believe it? I'll tell you the incredible story of this mission and what consequences we should expect now. And yes, scientists are very excited. What is this spacecraft? Voyager 1 is truly a legendary space probe launched by NASA from Cape Canaveral way back in 1977. Why was it sent? The probe's original mission was to study Jupiter and Saturn, but over time, Voyager 1 far exceeded scientists' expectations. Along with its twin, Voyager II, it not only successfully completed its primary objectives, but also continued its journey far beyond the original goals. In over 40 years of service, these space travelers passed by Uranus and Neptune and long ago left Pluto behind. Now that the planets are in the rear view, the Voyagers dedicate themselves to studying what seems like empty space. But this space is far from empty. It's filled with tiny particles, including atomic nuclei of hydrogen and helium. These elements are remnants of the solar wind that the sun continuously spreads across the universe, leaving traces of its influence even in the farthest reaches of space. These probes allow us to see farther than even the most advanced telescopes. But that's not the most interesting part of the Voyager 1 and Voyager 2 missions, believe me. Observation is good, but scientists decided to take bold action. One of the most thrilling ideas in the Voyager mission is the Voyager Golden Record, a true message in a bottle sent into the cosmic sea. What do I mean? The scientists came up with a brilliant move by attaching a gold-plated copper plate to the spacecraft. Even if the probe is destroyed or lands on a distant planet, it can still communicate with us. Brilliant, right? The plate contains various information about Earth and its inhabitants. The record has greetings in 55 languages, including ancient ones like Akkadian and modern ones like English. These greetings showcase the linguistic diversity of our planet and our readiness for interstellar dialogue in any language. But that's not all. Voyager also carries various musical pieces, from Bach to Beethoven, as well as traditional melodies and songs from different cultures, highlighting the richness of humanity's musical traditions. Recordings of natural sounds like wind, bird songs, and thunder are meant to convey the atmosphere of Earth. Visual materials on the disc range from photos of people of different ages and nationalities to images of architectural structures and everyday life, offering a broad representation of human civilization. The idea that the Voyager Golden Record might one day be found by aliens is more symbolic, but it's also an expression of humanity's hope and desire to establish contact and share our cultural and scientific heritage with possible extraterrestrial civilizations. Especially now that scientists have started receiving suspicious signals from the probe. What kind? I'll tell you more shortly. Voyager 1, launched into space back in 1977, is still considered one of the most important probes in human history. What does this thing look like? This probe, weighing nearly 1,760 pounds and standing 8.5 feet tall, has the shape of a 10-sided prism with a large antenna 12 feet in diameter attached directly to its body. A true machine. Its main task is communication with the stardust and transmitting data back to Earth. Because of the distant cosmic regions where solar panels are useless, Voyager 1 runs on radioisotope generators powered by plutonium-238. These generators initially provided 470 watts of power, but over time their efficiency has decreased due to the reduced activity of the plutonium and the wear of components. Currently, the plutonium reserve has dropped to 69.2%, but it's been flying for almost 50 years. The probe is controlled through 3 computer systems that can be remotely reconfigured, allowing it to adapt to new tasks and respond to unexpected situations during the flight. However, command signals take about 18 hours to reach the probe, making rapid maneuvers impossible. Voyager 1 carries various scientific instruments on board, from TV cameras with different lenses to spectrometers, magnetometers, and radio receivers. These instruments allow the probe to study planetary atmospheres, interplanetary space, and magnetic fields. Some of these devices are mounted on rotating platforms, enhancing their functionality and providing a wide range of research coverage. Although some of the equipment on Voyager I is currently turned off to conserve power, the probe continues to be an invaluable source of information about our solar system and beyond. It not only expands the boundaries of human knowledge, but also inspires new discoveries in space exploration. What kind? First, it made iconic flybys of Jupiter in 1979 and Saturn in 1980, collecting valuable data and sending it back to Earth each time. Humanity had never had a chance to do this before. But the real breakthrough came in August 2012, when Voyager I reached the heliopause, the boundary between the influence of our solar system and interstellar space. At this threshold, it began its journey into completely uncharted territory, moving at an incredible speed of over 38,000 miles per hour. Once it entered interstellar space, the spacecraft encountered a rare but calm environment where occasional disturbances were caused by solar activity. It was like a gentle rain, sometimes interrupted by storms from solar outbursts. However, when the storms subsided, scientists discovered that the interstellar gas was less active than expected. These moments of calm allowed for a better understanding of the distribution of plasma in interstellar space and the interaction of the solar wind with the interstellar medium. Through its studies of Jupiter and Saturn, Voyager I provided invaluable information about their atmospheres, moons, and rings. This greatly expanded our understanding of the processes that shape and alter planetary systems. These data helped for the first time to assess changes in density in interstellar space and improved our understanding of the processes that shape the heliosphere, our protective cosmic bubble. And still, this probe is racing forward at incredible speed. Voyager I is a true record holder among spacecraft. It has already set several speed records. On February 17, 1998, it became the most distant human-made object, surpassing Pioneer 10. At that significant moment, Voyager I had traveled 43,125 astronomical units from the Sun, which is approximately 6.5 billion miles. This phenomenal breakthrough highlights how far the Voyager space program, initiated back in the 1970s, has come. And although New Horizons, launched toward Pluto in 2006, started with a higher initial speed thanks to gravitational maneuvers, the Voyagers were able to accelerate, continuing their journey into deep space at a record pace. Here's an interesting fact. Due to the Earth's orbital movement, which speeds along at about 18.5 miles per second, the distance between Earth and Voyager I can decrease at certain times of the year. This happens when Earth moves in the direction of this distant traveler, even though it continues to move away from the Sun. But what were the strange signals from the probe? Why are they attributed to extraterrestrial origins? In 2021, Voyager I and Voyager II unexpectedly sent to Earth not their usual structured data, but a recording in a completely different format, in binary code. Essentially, it was a strange digital noise. Several theories explain these signals. Some scientists suggest that the strange hum recorded by the probes is the sound of interstellar matter. Others link it to the noise generated by powerful solar flares. There's also a theory that space beyond the solar system resembles a soapy foam, and the probes detected the movement of particles within this foam. This discovery was so unexpected that astrophysicist Stella Ocker from Cornell University proposed that these sounds could be used to measure the density and movement of plasma in interstellar space. These data helped scientists better understand the boundary between the solar system and interstellar space, which can be compared to defining a shoreline between them. In early 2022, researchers made another important discovery. It turned out that the Voyager probes, sent beyond the solar system, are closer to Earth than initially expected. This is due to the trajectory of the probes, which travel not in a straight line but in a spiral, influenced by forces within the solar system. Sometimes they align with Earth, allowing the data transmission modules on the probes and NASA's antennas on Earth to synchronize for effective information exchange. Moreover, the Voyagers transmitted data about a plasma bombardment that occurred on the night of March 31, 2022, which triggered a geomagnetic storm with a magnitude of 7. This event was one of the most powerful in recent years and had an impact on weather-sensitive individuals and those with chronic illnesses. These discoveries highlight the importance of Earth's protective layer and provide insights into the complexity of phenomena occurring in interstellar space. Recently, the probe re-established contact. The analysis of a new signal received from the spacecraft in 2024 became an important step in attempting to restore its functionality after a series of failures, during which it only transmitted meaningless binary data that alarmed scientists. The Deep Space Network team, responsible for deep space communication, reported that for the first time in several months, there was hope of receiving meaningful information. The new signal, recorded on March 3, 2024, although it did not conform to the standard data format used by the spacecraft, turned out to be extremely useful. It contained a complete memory dump of the flight data subsystem, including not only the spacecraft's software and executable instructions, but also variables that could change depending on external conditions and control commands. This information became key to potentially resolving the accumulated issues. Now, with access to the full memory data, NASA specialists can compare the current parameters and code with those from before the malfunctions occurred. This will allow them to identify possible errors or changes that may have led to the probe getting stuck in the mode of sending random data. The signal appears to have been a response to a command sent by scientists on March 1st, indicating that the spacecraft is still capable of responding to interaction attempts from Earth. Or perhaps aliens fixed it. Given the enormous distance of 15 billion miles that Voyager I has traveled away from Earth, every command sent and every response received takes nearly a day to reach its target. This adds complexity to the process of diagnosing and fixing errors, but every step forward is seen as a great success in this monumental project. But let's think about how far the probe could have traveled by now. Many media outlets have claimed that the spacecraft has already left the boundaries of our solar system. But NASA clarifies Voyager I and its sibling Voyager II are still far from fully exiting the solar system. Estimates suggest it will take about 30,000 years. Quite a journey, right? But despite that, the distances they have already covered are mind-boggling. As mentioned, by August 2012, Voyager I reached the boundary of the heliosphere, the region where the solar wind still has influence, having traveled 11 billion miles by that time. By 2018, Voyager II also confirmed its exit beyond the heliosphere, entering interstellar space, a region between star bubbles. In 2019, the journal Nature Astronomy stunned everyone by publishing studies based on data from these space travelers, which for the first time observed interstellar space. Moreover, in 2021, NASA reported that Voyager had detected the first interstellar sounds, and then began sending mysterious signals. As of now, the probe has traveled about 18.5 billion miles and continues to operate. It's exciting to think about what it will discover next and how far it will go. Communication with it has been restored, and recently all 4 trajectory correction maneuver engines were activated, which hadn't been done since 1980. This maneuver was necessary due to the failure of the thrusters and allowed for a successful course correction. This confirms that scientists still have big plans for this probe. Unfortunately, over time, due to the decreasing availability of electrical power, the decision was made to gradually shut down some of the onboard instruments, as I mentioned earlier. About half of the equipment has already been turned off, but the most important instruments for research are still functioning. The cosmic ray subsystem, the magnetometer, the plasma wave system, and the low-energy charged particle detector. In the future, data recording and gyroscopic operations are expected to cease due to further reductions in available power. Predictions suggest that by 2025-2036, Voyager I will completely exhaust its energy resources, and none of the instruments will be able to function properly. After 2036, the probe will be beyond the reach of the Deep Space Network, making further communication with it impossible. It is truly sad, given Voyager's contribution to science, but such is the law of life, even for space probes. I hope that before then, it will continue to surprise scientists. In a good way, of course, since we wouldn't want to learn about an intergalactic invasion of our solar system. Agreed? Share your thoughts in the comments, subscribe to the channel, and I'll do my best to stay on top of things. And yes, if you love interesting stories, know how to write scripts, edit, or voice videos, head over to the Telegram bot linked in the description. I'd be happy to collaborate with you. Thanks for watching, friends. Posts.